Hi, how are you? I am Bruno from Erix, and today I will be talking about our zkLogin project in Cardano. We entered Fund 14 of Project Catalyst under the Cardano use cases category, addressing one of the most fundamental barriers to blockchain adoption: authentication. Cardano today requires users to manage a seed phrase, and for someone coming from Web 2, it's a deal breaker. We asked ourselves, what if you could access a Cardano wallet the same way you log into any app, with your Google account without giving up custody or privacy? That's the idea behind zkLogin, and we believed it was possible to implement it entirely on top of Cardano existing infrastructure using Icon smart contracts and Circom zero-knowledge circuits. The core technical insight was that we could embed a user's identity into a validator, use the validator's hash as their wallet address, and verify a zero-knowledge proof of a valid Google login inside that validator. We organized this over 4 milestones. Our first milestone focused mainly on research. We studied the existing implementation in Sui, designed our flow, and created a technical document. The second milestone was the core of the protocol, a Circom circuit that proves that a JSON Web Token is valid and that the user's credentials were derived from it, paired with an Icon validator that verifies the corresponding GROT16 proof on chain without ever seeing the JSON Web Token itself. The third and most technically demanding milestone introduced full OpenID provider signature verification. The validator now checks that the JSON Web Token was actually signed by Google using their published RSA public keys. This is what closes up the trust loop and makes the protocol truly secure end-to-end. The main challenges we faced along the way were: first, adapting a protocol that was native in another blockchain to the extended UTXO model in Cardano, building the exact transaction we needed to unlock the funds in a zkLogin address, and mainly finding the same primitives with the same parameters in Circom and TypeScript so it will all be consistent. Despite these challenges, we delivered everything we committed to, and the code is fully open source under the MIT license and available in GitHub. Okay, let's see how this works. First, we're going to create our temporal credentials, public and private key. Then, continuing with the temporal credentials, we are to fetch the current time, generate a random value, hash to get the nonce, and log in with our Google account. Then we parse the JSON Web Token and move on to the salt, where we are going to use our previously used salt. Then we are going to generate this value, the zkLogin ID, hashing the JSON Web Token values, and with that we're going to derive the wallet address. This is our wallet. Then we're going to generate some session data for the proof generation and move on to the proof generation time. This may take a while, so see you in a bit. Okay, so the backend generated the proof, and now we can move on to giving funds to our address. We already did that, so let's go to transferring funds from that address, and we're going to transfer to itself, but it can be done to any other address. And we can see that the transfer occurs successfully, and we can see the last transaction hash in Cardano scan. So, what's next for us? This project was always conceived as a foundation, not a finished product. The next natural steps are extending support to multiple OpenID providers beyond Google, so each user can choose the provider they already trust. We also want to explore making zkLogin addresses wallet independent so users aren't tied to a specific application. Staking compatibility is another important direction, and we believe that's solvable. We want to explore further funding to pursue these extensions and to support wallet teams who want to integrate zkLogin into their products. zkLogin is a concrete answer to the onboarding problem. It lets anyone with a Google account access a Cardano wallet they fully own and that no third party can control. The privacy properties are held. Your Google identity is never visible on chain, and the security model is designed so that no single party, not even Google, has enough information to act on your behalf. We believe this is a meaningful step towards making Cardano accessible to the next wave of users. Thank you for watching and see you next time.